Welcome to Season 3 of MTE's Plugged In Podcast. This season, we will continue to explore the world of electric vehicles. Whether you're a seasoned EV driver or you're just beginning your journey into electric vehicles, this podcast is for you. For a more enhanced experience, be sure to watch the video version of this podcast that will be linked in the show notes.
Hello, everyone, and welcome to this episode of MTE's Plugged In Podcast. I'm Brandon Wagoner, and as always, I'm here with Amy Byers. Hey, Amy.
Hello, Brandon, and today we want to welcome to the podcast Adam Miller. Adam is one of MTE's electrical engineers, and he has been working on some solar projects for MTE, and we're excited to have him on here to talk a little bit about that. I mean, I know, we're not really focusing on the EVs today, but I think the people that are enjoying the EVs and driving the EVs probably would find some of the stuff that we're doing in the solar realm pretty interesting. So before we get started, can you tell us a little bit about yourself and what you do for MTE?
Sure. I'm an electrical engineer, and I started here in 2017 as an intern, and I interned 2 summers with Larry Taylor. He was the engineering technology supervisor, and he's since moved on to the substation testing team. So now I work under Avery Ashby, and I've been here full-time going on 5 years.
Yeah, we've had Avery on the podcast before, so I'm sure that's fun working for him. So recently, MTE announced a couple of different solar projects, and one of those you were heavily involved in, and can you tell us a little bit about that project?
Sure. So we have an existing solar field located in College Grove, and it's about a megawatt of DC production. We're working on a project that is about 5 times that scale of DC production. The AC output will be 3.25 megawatts, 5 megawatts DC. So we're working with Silicon Ranch on this project, and it's a little different because we're not used to a project this size to where it impacts the grid so much. Typically, we're on the lookout for things that may cause voltage disturbances. And this project specifically is going to be feeding back into our substation, which we typically don't allow, but working through some of the design of it and all the relay settings, turns out we can host it. We just have to be careful about how we do it.
Yeah, a lot of engineering behind that. Yes. Definitely.
Mm-hmm. So 3.25 megawatts. Now you mentioned the 1 megawatt at College Grove. That one, I think, is it fixed axis?
It is fixed axis, so you really only get max production maybe 4 or 5 hours a day, usually between 9 or 10 a.m. to 3 p.m.
Okay. And how does that fare during pollen season?
There's not a huge reduction in production.
Yeah.
But it does affect it.
Yeah.
We have to get those panels cleaned probably once a year, and it takes professionals to do it. So it's not a small project.
Yeah.
The 3.25 megawatt system we're installing it's a single axis system where it tracks the sun. Okay. So on your X plane, so it can follow it from east to west throughout the day. So you're getting peak production longer throughout the day.
So I know Avery's told me in the past, like you want to kind of aim them south, and then so this one just kind of goes along. Okay, so what does that do as far as output goes? Is that, I guess it's more output than a fixed?
Yeah, so you'll get the same output during the middle of the day, but what it does is it'll face southeast at the beginning of the day, so you're getting a more direct face to the sunlight, which in turn you get more production earlier throughout the day. So then you're getting full production longer. So our fixed axis at College Grove, it's going to vary. It's going to may only be 100 kW in the morning, and then around 10, 11 o'clock it'll start to peak at a megawatt, but then it drops off again at 2, 3 p.m. To where the 3 megawatt system, it's going to be full production at 9, 10 a.m. all the way till maybe 4 p.m., 5 p.m. Okay.
So I know that has impact on our demand costs as well as just the energy. And I will talk a little bit about some of the program this is under and how that works. But obviously that causes a little more headache to you, right? Because ideally you want your full production of your solar to match your maximum energy draw at the substation so you don't backfeed in. But you're going to have that maximizing longer. So as Amy said, this isn't quite EV, but we're kind of leading the way as far as utilities go. We're hosting this, it's going through the substation, it's kind of stretching our team maybe a little bit. Obviously, you said we can host it, so that means that there's a limit and we can't host just anything. Talk to us a little bit about what all has to go into sizing a project.
Sure. So typically we do what you call it a load study. And what it is we take historical data from our field relaying. We plot it in a graph and it tells us what your peak output is throughout the day, usually at an hourly interval. So we can take that data and compare what the output of the solar is going to be at a site. And you don't want it to exceed what the historical data presents. So what we do is we have a threshold. It's called a penetration threshold, and it's pretty well known throughout the solar community. But what it is the penetration into the grid from your solar. I guess the ideal, the sweet spot, you want to be about 33%. What that does is it allows a certain amount of production before the upstream field relays are desensitized, which means anything upstream of a production source, it's not going to see fault data. So if it's exceeding the amount of load that's coming through that relay, if a fault happens downstream of the relay, you're not going to see it. Okay. So we're trying to avoid that. And then the 33% also allows for the voltage tap changer at the substation transformer not to tap so rapidly. So you're not seeing voltage fluctuations, which causes flicker at people's homes. Mm-hmm. Sometimes you'll see your lights dim. That's typically what's happening.
And so you've got a substation, and at the substation we have our tap changer so that we make sure that as the load increases, it pulls the voltage down. We have to tap it up to make sure we are giving folks the voltage that they're needing, and then vice versa when the load drops off. So then right past the power transformers, you've got your breakers, and then you have reclosers out in the field, and then you have fuses eventually when you get to home. So, talk to us a little bit about when we say breakers, I might think about the breaker in my home, right? It's just like a little thermal that just flips.
That's right.
But these are like computers, right?
Yeah.
What? Tell me a little bit about those.
So they are smart relays, and they read telemetry data, your voltage, your current, your kW, and they can sense faulting. So anything upstream or downstream, that your fault current's going to jump immediately, and it senses that within a couple cycles, so hundredths of a second. And what it does is it opens that switch. It's just like a light switch you have at home or a circuit breaker, like you said. So it opens that switch so it doesn't feed into the substation. And what it does is it just isolates it downstream. And what we can do with those is there's multiples on a single line, so we can isolate that fault based on where it's located. We can also reroute power with those switches. They call it sectionalizing. Okay. So if somebody's out, we can kind of pinpoint where the fault is and kind of reconnect devices around the fault. So it brings more people online.
Okay. So your goal is to isolate a fault, but not upstream as downstream as much as you can, so minimize the outage, and then putting distributed energy resources, or we say DER a lot, putting that in the system. Now you're messing with, I'm guessing, zero sequence currents, and it's messing with your relay, and so that's what you're talking about, is you're having to put that into the whole coordination scheme to make sure that you're not taking people out that as a result of this on.
That's right.
Okay. Yep. Okay, so Adam, I know we're getting a little deep in the weeds here, but the point is, we hear smart grid, and what you're basically telling us, this is what smart grid is. There's electronics, there's computers, they're all talking to each other, and it's more than just poles and wires.
That's right. You can think of it just like he said, your house breakers or a light switch even. It's just on a larger scale.
So y'all have been engineering talking for the last. So I'm going to interject here and ask. Let's bring this down a little bit to first of all language that I can understand and other people listening can understand. But when we talk about, we're putting this up, and I heard you mention there were a few words that I got that you mentioned, and one you were talking about demand, and I know we've talked demand before in other things. Demand is, and you maybe could do a little brief summary of what demand is. That's kind of part of how we pay TVA and that type of thing, and with these solar panels and solar projects kind of offsets that. So down the road, the members could save some money or whatever. So let's circle back to that demand portion a little bit, and let's talk about that and why we're pursuing this, to where that could actually save and help our members in the end. Does that make sense?
Yeah, okay. That makes sense. So, this project has multiple benefits, and really it is part of TVA's flexibility program. So a few years ago, TVA proposed to the local power companies it serves an opportunity to become long-term partners, which we agreed to do that. And part of that agreement was an allowance of 5% of our energy could come from someone other than TVA. And so that was brand new. That was revolutionary, honestly. Yeah. TVA had an all requirements clause up until that point. And so when that became an option, we started looking at what are the opportunities for us to get that 5% of energy. And this particular project is only a portion of that 5%. The 3.25 megawatts is really less than 3% of the total capacity we have. But it gave us an opportunity to get energy. And when we do something like solar, as Adam said, it's more complex than just hooking up a solar array and going. So there's got to be some sense of worthwhileness to it. And besides the ability to get this energy cheaper than we were buying it from TVA, so there's a savings there. There also is an opportunity to be a good steward with our members' resources, right? I mean, we talk a lot of times about EVs, and we say we're not pro-EV or anti-EV, but EVs are here, and we want to make sure that we're opportunistic about it. And this is, I think, a very similar situation. Solar in the right instance, and we think this is the right one, is an opportunity for us to make an impact for our members and be a good steward without sacrificing anything that's important to our members.
I think what you said there is real important, that there are right instances for solar, and there are wrong instances for solar. I know everybody's like, well, we have the sun and we should all be solar, and that's just not realistic, because the sun doesn't shine all the time. We have the pollen problem we talked about earlier. We have rainy days. We have it's not consistent, it's not reliable for just powering everything, and even on people's homes, the equipment can be so expensive that you're never going to get that payback that you think you're going to get, And so there's a lot of instances where solar in our area in Tennessee, like if you're in California or other places, that may be an option, but where we are located geographically, it's not always the best option. But what you're saying is, in this instance, how we were doing it, to where you had said like the panels move with the sun and different things, and what we're actually using it for is a very good pro use of solar.
Mm-hmm. And Adam, maybe you can talk about how much land this 3.25 megawatt site takes.
I think the standard is about 5 acres per megawatt. So with 5 megawatts of DC power, you're looking at 25 acres, and that's minus all the relaying that's being installed, the transformers and the feeder and everything else. So.
And single axis trackers take up even more land than a fixed system, I believe, because you have to space them out maybe a little more. Or?
Yeah, and there's a lot more, conduit and stuff to be run, because the motors, they're not always powered by the solar. Sometimes they're powered from the utility. So
And so that's part of the whole conversation too about when is solar right. Well, land is not, that's the thing. Solar prices have come down, right? But property prices have not. And so, and finding property. Yeah, exactly. And finding property that is where there's a power line adjacent. So that's where the cost really comes in, and I think it kind of hurts a lot of the financials on our projects. But this happened to work out. So tell us a little bit about, you mentioned we're partnering with Silicon Ranch. What is, you told us a little bit about what MTE is doing. You're responsible for hosting this in a way that doesn't affect reliability to our members, which we know there's a lot goes into that. But what is Silicon Ranch's part of this?
They're essentially the contractor. It's pretty much a turnkey solution. They're doing all the install, all the commissioning. We will be on site to help with the commissioning process. We have certain standards that they have to meet. So we need to be there to make sure they meet those standards. But everything else is pretty much hands off for us.
Okay. And so they've designed the system and they procured the panels and all that stuff. And I know this is a they're really proud of this, and we are too. There's a feature to this system called cattle tracking. And there's a whole thing I didn't realize about agrivoltaics. Tell us a little bit about that.
Agrivoltaics, it's essentially dual use property. It can host both solar panels while preserving crops, for instance. Okay. The only issue is space constraints. So it may have to be crops where they don't require a combine or something you have to probably harvest by hand. And then you can also dual use property with solar and cattle. It can provide shade for cattle or a place for them to graze without sacrificing the land specifically for solar.
Okay. So. Well, that's something I hear all the time is I don't want to give up this land. I could do so much with it, but now we're talking about you can do two things at once.
Yeah. That may be, once this project gets going, everything, that may be something we can talk more about after this is all done, maybe next season's podcast. I know we're getting near the end of this season, so maybe that's something we can revisit and talk about the cattle tracking, because that's a very interesting topic, I think.
And when does the commissioning on this happen?
We're looking at end of May, early June. It took a while to get started with the project. There was a lot of interconnection issues we had. Got them all worked out. They've been doing construction pretty well for a couple of months now. It's moving pretty fast now.
Okay. That's great.
Yeah, they're hoping to hit a deadline end of May for production, not quite letting it go freely. We'll have to do some testing and stuff, but we're looking at May, June.
Well, we'll certainly circle back on this topic. Maybe it'll be one of our first few episodes of the next season. So that's great. This question is probably maybe for both of you, because I know, Brandon, you're pretty involved in a lot of the things that we do in this solar realm as well. But can you tell me a little bit why MTE would pursue a project like this?
Yeah, I think the big word is being opportunistic. And when flexibility gave us that opportunity to look at generation options, this is a really interesting project. There's a process called a PPA, which is basically the way it works is, you mentioned Silicon Ranch does the turnkey. They own the asset, and we just buy the energy as it comes off. So essentially there's no investment from MTE. And every time we're buying that energy, and it happens to be less than what we're buying from the TVA wholesale side of things, there's a net savings for us and for our members. So this is certainly one of the ways we're trying to diversify our generation mix in a way that has also financial rewards and downward pressure on rates, hopefully keeping rate stability for years to come.
Well, I think in everything that we do, when we talk about our rates and our services to our members, we are owned by our members. They are part of this cooperative, and our mission, we have to be good stewards of the money that we get from them. And I think that's our goal, is always trying to look out for them. We're never in it to make money. We're nonprofit, so that's not the end game for us. The end game is to look out for that member. So, well, Adam, thank you so much for being here today. This was even though I will say some of it went way over my head, it was very interesting conversation. So I really thank you for joining us today. And thanks to everyone out there who was listening today. For more information on MTE's Drive EV programs or the EV Car Club, you can visit driveev.com or email us at evcarclub@mte.com. That wraps up Season 3 of MTE's Plugged In podcast. Thanks so much for tuning in this year. We'll be taking a break for the summer, but don't worry, we will be back in October with fresh topics, new insights, and exciting interviews you will not want to miss. Until then, plug in, power up, and drive safe.